For the moment, actually, the last time is it. Like, I'm skipping my next class only for what? An hour and 30 minutes before I get my juice. I gotta take my juicer with me.
You know that story?
This
woman brought her cat into the bed because it was like skinny and falling over and
Are you comparing me to a cat?
No. This has no comparison. This
All right, guys.
And they were feeding it and all the vegetarian diet.
So this is not in response to the request to not turn this in, but I lied to you. You can keep this. I just have to tell you that you're going to turn it to me so that you're nice to yourself and actually do nicely. So now you have this to reference. We're going to talk about these right now. First few, hopefully, by now you guys get the idea here. I mean, the square root of 36 is 6, because 6 times 6 is 36. Square root of G12 is, because G6 times G6 is G12. So now you realize, oh, I do just cut powers in half. But then you understand why I get people that say, when I say square root of 36, they tell me 18. And that has happened before, because they said, well, you said cut it in half. No. A number acts a certain way. A power is not going to act. Look at that 8. That's awesome, Jeff. A power is not going to act the same way. You with me? That's why you guys were looking at me like, what's up with you? Do you guys understand? I was thinking ahead to that example. You don't treat... Now watch. With what I just said, how can I rewrite 36? It would be 6 squared, right? Now go with me. 2 goes into 2 once. 2 goes into 12 6 times. If you write the number in the same form as this, then they must act the same. But if you don't, you can't expect them to act the same. Does that make sense? So math is not doing 2 different things. Math is always doing the same damn thing. It has to. What's up? You all right?
No, I get some.
Sweet. It's my favorite phrase. All right. So what about 1b? Now 1b is relatively easy if I write it correctly. Well, cube root of -8. Good, because it takes 3 of these to make -8. 3 goes into 12 4 times. So real quick little side problem. What if I had the 6th root of a to the 12th, b to the 24th, c to the 600? Yeah. A squared, b 4,
100.
100. All right, see, easy.
It's because I think that.
All right. So that's part B. Part C is different from part A and B because it's minus and plus. A and B were easy because the only operation on the inside was multiplication, so the square root could just attack it. So the first thing I got to do is make it multiplication by factoring it. Of course, you guys got x minus 4 squared. These effectively cancel because they're opposite operations. But you can't just write your answer like that.
Absolute value.
You got to cover your ass in case it's negative. I like it. Okay. So what about D? Lock it. Okay. So the cube root of 27 is 3, and the cube root of 125 is 5. Kick ass. You start to see a lot of numbers that you saw when you were factoring squares and cubes, because factoring squares and cubes is like taking square roots and cube roots. Okay. E. So here's the neat thing. Let me show you the long, drawn-out way, which somebody actually came up with on their own, which I thought was really, really cool. And then I'll show you what that means in terms of a shortcut. So here's a long-ass way to do this, at least the first couple steps. Can't I rewrite this as 5 to the 1/2 times 15 to the 1/2? Can I? Yeah, all right. And think about it. If I had a squared, b squared, isn't that the same thing as ab squared?
Yes.
So I can take the 1/2 power out the same way. This would be 5 times 15, all to the 1/2. Well, what is 5 times 15? 75. Square root of 75, right? Alright, so look at the shortcut. All this crap. If they're the same root, what am I allowed to do? Multiply. We've been doing that forever. What's 3 times 4? Why were you able to do that? Because they both have the same root, namely no root. So as long as they have the same root, you can just multiply them or divide them. Now there is something you can do with this. Believe it or not. And I'm just going to hold on to that for a second. We're going to move back to that because I don't want to. I want to talk about that more. Huh?
525. No. 325.
No.
I did something.
Well, let's maybe I'll talk about it. Now, give me a second. This is going to be weird. I don't care. How do I rewrite 9/8? Now, you're all like, what the hell's it got to do?
1.
Yeah, and why is that? Because I'm trying to divide 9 by 8. I can't divide 9 by 8 evenly, right?
Mm-hmm.
But 9 has something in it that I could divide by 8. Namely, it has 8 in it. Are you with me so far? So what I'm doing right now is analyzing an easy problem that you know how to do quickly, but I want to overanalyze it so I can do a harder problem. That's kind of like how we do some of math. So 9 I can write as 8 plus 1, a number that I can divide by 8, and a number that I can't divide by 8. You with me so far? I don't know if any of you have ever seen it like this. And so I say, okay, now I divide 8 by 8, and I divide 1 by 8. What's 8 divided by 8? 1. And 1 divided by 8, I don't know, shit. So what does that have to do with anything? Well, square root of 75 has a number in it that I could do the square root of. The same way that this had a number in it that I could divide by 8.
25.
Yeah, square root of 75. Oh, I'm talking like that. Square root of 75 is the square root of 25 times the square root of 3, right? What is the square root of 25? What is the square root of 3? I don't know. Square root of 3. So it's just the same thing. It's actually a lot like making a number, an improper fraction into a mixed number. You do the part you can, and you leave the part you can't, because you can't do it. Shit. So if you typed in your calculator square root of 75, somebody help me out. You guys know where your square root button is? What's the square root of 75?
8.66.
Wait,
8.66.
8.666.
025.
And what's 5 times the square root of 3? If they're not the same, we'll just all leave it.
8.6.
So you had a chance there, but 8 point. You could have said 7 point. I'm gone. They're the same thing, of course. They're just rewritten. So I didn't do the square root of 75 by hand. I simplified it. Sort of like if you said 6/8. What do you think I'm going to say? If that's your answer to a problem, what would I say? I'd say you're not done. Come on, right? So if you say square root of 75 is an answer, same way. It's not reduced. Now this is called simplifying a radical, but I call it reducing a radical because it's a lot like reducing a fraction. It's the same kind of idea. They're both the same damn. 6/8 is the same damn number as 3/4, but 3/4 is simplified.
Just to make sure that 5 times the square root of 3 is different from the third root, right? Like if
So
you-
5 times the square root of 3. Yeah.
is that different from the third root? Like, see up there, how you have 3 in front of the.
Yeah, I've got to be careful because otherwise this might look like the 5th root of 3. Is that what you mean?
Okay. Yeah, that's
so
what I
if
mean.
5 is in here, that means that's the 5th root. If the 5 is a coefficient, that's 5 as a coefficient.
So you just have to be careful not to.
Yes, that's why you thank God that I type my test. I don't handwrite my tests, right? Even then, you should come up and check with me if you're not sure. If you're like, is that 5 in there or out there? I'll tell you. But you guys, with that, that's a good point.
Yeah.
You got to be careful if it's a coefficient or is it actually the root, right? Okay. So we'll do more of these here in a minute. Where are we at here? A, B, C, D, E, F. Oh yeah. So this, I thought this would be the hardest problem that you were actually able to do, based on what we've lectured so far. This got a lot going on in it, and what I normally do with this problem is I got to raise 64 to a negative, and I got to raise it to a 2/3 power. So the very first thing I do is get the negative out and done. What does the negative power do? Flip it. So I'll make it 1 over 64, but what do I still have to raise it to? 2/3. So I did the negative power, bam, and I still have to do the 2/3 power. I haven't done that yet. Do you guys see that? All right, good. Now here's where it comes into play what I said earlier. Which one of these is the root? Good. So I could write cube root of 64 squared. That's not preferred, because square 64, you get kind of a big number. Is it easy to take the cube root of that? No. So remember, you have the option. You can put the square on the outside. That's the same thing, right? And the cube root of 64 is relatively easy. 4. And what's 4 squared? 16. Cool. Now, let me show you a little bit different way to do this. It's not a really great way to do the problem, but it's nifty to realize. 2/3 of 64. Well, if you break 64 into 3 parts, you get 4, 4, 4, right? Is that cool? And then 2/3 means take 2 of them. That's why I end up with 16. 2/3 of 64 multiplicatively. 2/3 of 64 multiplicatively would become 16. Because break it in thirds, it's 4, 4, 4. Take 2 of them, that's 16. If you don't like that, I don't care. Just do it the way we did it. It'll come out the same way. It's kind of nifty to realize that's what it's saying. All right. Sort of like, what's this? What's 2/3 of 9? Well, the quick way to do it is 3 goes into 9 3 times. Well, so 1/3 of 9, break 9 up into 3 parts. It's 3 plus 3 plus 3, right? And then take 2 of them. 6. It's the same thing. Holy shit. All right. So let's see where we are. G. Now that we've talked about this, G should be relatively easy. So it's a cube root. So when I'll break the number 80 up into something I can do the cube root of and something I can't. And a little side note, a really, really good idea for you is to make sure you know your squares up to like at least 12. Right? Make sure you know your cubes up to maybe, I don't know, 5 at least. Right? 5 cubed is 125, we saw that. Know a few 4th powers. You should know 2 to the 5th. You should know that 5th power. 2 to the 5th is 32. So if you see the 5th root of 32, you just know it's 2. Right? So you got to know some of these things. And the reason it's really good to know these is because then I know what to try to break this up as. Yeah, 8 is a cube. So, and this is 8 times 10. Yeah. So if 8 didn't go into it, I would try 27. Because 27 is a cube. And if that didn't work, I'd try 64. Okay? Of course, if 8 doesn't go into it, 64 ain't going to go into it. But anyway. All right, maybe. So now I can rewrite cube root of 80 as the cube root of 8 times the cube root of 10. Are those the same? Because what is the cube root of 8 times the cube root of 10? It's the cube root of 80. I like it. Because you're allowed to multiply them as long as the roots are the same. So if this is the cube root of 8 times the square root of 10, you'd circle that and just be done. You're like, I can't do shit with it. Thank you. Well, now, actually, you could. What is the cube root of 8? 2. And what's the cube root of 10? I don't know. Shit. So you just leave it. I never want to see decimals. I'll tell you. I might give you a problem where I say, do square root of 11.8 in your calculator. Just make sure you know where your square root button is. Then you can give me some decimals. I'll tell you where to round. But on these problems, don't show me freaking decimals. All right, I don't want your calculator doing that for you. Right? I want to see this. Okay, let's see. H. So H and I are like the same thing, really. With H, what property do you use? Yes, so you got to multiply like bases, you add the powers. The LCD will be 24, good. So it'll be A to the 3 24ths times A to the 20 24ths, so you get A to the 23 24ths. Cool. And if you wanted to, you can make that into the 24th root of A to the 23rd power. Okay. I. Same thing here, except what I'm going to do with the power is I'm going to subtract the LCD would be 20. So this will be
25 over 20 minus
25 over 20 minus
12.
12 over 20 gives you b to the
13.
13 over 20. Cool. Alright. Okay. And then the bonus, let's see, I got around to a decent number of people. You guys get this here? So the bonus, I like that part of the problem is just understanding what the hell it's got here. It's kind of hard with all these layers. So I'm cutting y in fourths and then half and then thirds, right? So the way to officially do this, and then you'll see a shortcut, is to rewrite all this in powers, in exponents. So this will be the cube root of the square root of y to the 1/4, right? Does that make sense? Because a fourth root of y is y to the 1/4. Now what's the square root of something? It's that thing to the 1/2. Is that cool? And what's the cube root of something? It's that thing to the 1/3. And of course, what do you do with all those? Multiply, because when you raise something with power to power, you multiply. So it'll be y to the 1/24. So the shortcut is 3 times 2 times 4. It's 24. It's the 24th root of y. Isn't that what that is? Yeah. So that's what you do. If you cut something in half, and you cut it in thirds, and you cut it in fourths, you end up having 24 little pieces of pizza that it's like, thank you so much. I'm done. Buy some more pizza. All right. So any questions on that worksheet? Okay. Now, I like it that some of you guys are still kind of like grouped up. Let me give you this. This explains the, simplifying square root of 75. This explains that a little bit more fully. No, you can keep it. I'll put an extra one in. Cool. I'm going to put in just for you. Everybody good? Good. There he goes. Hey. She was like in her own row. I didn't know what to do. Alright. So guys, a quick couple examples and then I want you to work on this. I give you two main methods to do these. So, and I'll finally talk about this guy here. So the way I would do this is I would break it up into a part that I can do. If I said how many extra x's are in there, what the hell would I mean? If only that was a power of what, then I could do the square root. If it was a power of
3.
No, I couldn't do the square root of x cubed.
Oh, it's like cube.
Like, no, I'm not saying change the root. So, why is this easy? Why? What's that? All right. So now thinking about this, how many extra x's are in here? 1 extra x. So if I write this as x to the 8th times x, well, what's the square root of x to the 8th?
See where you're going.
And what's the square root of x? I don't know. You with me?
Yeah.
Now here's a nice shortcut if it's a variable I'm looking at. You ready? This is awesome. This one kicks so much ass. And I don't think I put this on the sheet because this is all numbers on the sheet. What's the number here? 2. 2 goes into 9. 2 goes into 9. 4 times with 1 left. Holy shit. Right? Let that be easy. real quick, if I had the fifth root of A11, B27, sure. 5 goes into 11 twice with 1 left over. You guys with me?
Yeah.
This is almost too easy to believe. 5 goes into 27 5 times with 2 left over. Do you see that? It's a shortcut of doing this. I actually don't even write the parts out. I just directly go and see what would the remainder be. And what's awesome is the remainder remains inside. The words make sense. That's crazy. But now getting back to numbers. So if I had, what do I got here? You can do it, Jeff. Can I? Sure. Thank you. Square root of 28. So the two main ways to do this, the way that I personally do it, is to break it up into 7 and 4. Exactly. So this would be square root of 4 times square root of 7. Square root of 4 is 2. Square root of 7 is 7. Or you can break this up all the way down. And the square root looks for groups of 2. So for every group of 2 things, you can take one of them out. 7's all alone.
So it stays in square.
So it stays in 7. Yeah. So either way you like better. You can do it that way. I don't care. So go ahead and try to do the problems on there. And just to warn you, they might not all be able to be done. I can't remember now. Oh yeah, I knew I put at least one of them down there. Sort of like I say, factor this in its prime, right?